Hi, I'm Randy Levensalor. I'm a principal architect at CableLabs, and I'm coming to you today from sunny Boulder, Colorado. If you're not familiar with CableLabs, we're a nonprofit R&D organization who works on behalf of the global cable industry. So if you've used broadband internet, you've probably used some of the technology we've helped develop at CableLabs. Today, I'm excited to be here to talk to you about developing and managing cloud native applications with hardware acceleration. That's right. We're not just doing it in the cloud. We're going to go faster. So, edge computing, just a quick recap. I think we've all been hearing about edge computing all week. It's great, it's awesome. But really, why do we want to use the edge? Partially because it's faster, there's lower latency. We're going through all this trouble to move the compute closer to the customer, to reduce the number of hops, and to reduce the latency on that transport network. But you don't want to waste that time on a slow CPU. You may need to have the right compute for the right job to get the best performance for latency. Also, with high throughput and security, there's a lot of need for hardware acceleration. Things like using GPUs or graphical processing units to improve video gaming or video transcoding. You can use FPGAs for doing stream processing at line speed without actually having to cross the PCIe bus. With security, you can actually offload your encryption and reduce the power and the time you need to perform common security functions. Right. So at CableLabs, we've really been working on this for a couple years now. Earlier this year, we announced Project Open Adrenaline. And with Open Adrenaline, it's really an open community where we're trying to bring together everyone who wants to work on hardware acceleration. Doesn't matter if you're a service provider, a Kubernetes orchestration provider, a hardware provider, or an application developer. We're really trying to bring all this knowledge together. And we want to really kind of help this be a focal point. We're not trying to kind of fork Kubernetes or anything. We're really trying to work within the existing open source communities, but we want this focus here. And with this, you can actually, start enabling and improving your performance. One of the concerns we hear is, FPGAs use a lot of power, which is true. They do use more power than a server without an FPGA. However, there's been some studies where if you are using an FPGA, you only need a third of the number of servers. So you're much higher density, and you can actually be lower power consumption since you go from 3 servers to 1, even though that 1 server may be using more power than one of the 3. So again, some of this will depend on workload, some of it will depend on generations, but we really want to enable this flexibility. So let me talk a little bit more about kind of what we mean and why we're looking at this area. Part of this is we're looking at platform convergence. So we're actually able to reuse some of the software applications, some of the compute modules, and now we want to bring hardware acceleration into that, where we can actually reuse this in the edge. So this could be in a head end or hub. It could be in a node. So you can actually have a compute module with hardware acceleration hanging from the wire of your telephone pole nearby. We can actually do this on cell sites and put large pods of servers at cell towers, or it can be on the customer premises. Really, it doesn't matter where this is. You can use your imagination for how close you can get the compute to your customer. And we want to enable these same orchestration layers. We want to enable the same industry standard servers. So you can use standard, x86 64 compute. But if you have a need to do hardware acceleration or some higher network throughput or security, you can actually use this hardware in the same manner that you would access that standard compute. So again, why are we looking at acceleration and edge? Well, if you look at these applications we're seeing as leaders for the edge, pretty much all these have some kind of acceleration opportunity. Cloud gaming, AR, VR, video, those can all benefit from GPUs. Machine learning, that can go better on GPUs, FPGAs, or other special processors. And with the edge, right, we're going to have a lot more data than we could backhaul to a central cloud. So we're going to want to do federated learning and looking at data analytics on the edge, so that way we can get a better picture with higher resolution data without actually having to upgrade all of those backhaul pipes and backhaul it all the way back to the cloud. So let's talk about how you actually use it. So first I want to talk a little bit about how the application developers can access this acceleration. And to be honest, with Kubernetes, it's really nice and fairly straightforward to do this. So if you've done any Kubernetes deployments, this pod file should look very familiar to you. Right? You have your container, you point it at an image, and you ask for some resources. Typically that'll be CPU and memory, but actually you can add acceleration where you have the vendor name and model or type. Again, this is somewhat configurable, but this is how it's advertised in the system and the inventory is managed. And for this, we just ask for 2 instances of our hardware acceleration. That's all. All right. When we do this, this will, when we use the Kubernetes scheduler, it will find a node that has that available compute and memory resources and that hardware acceleration available on it. If that's not available, then you'll get an error message that says, hey, we can't schedule it. It's not here. So that's really kind of some of the straightforward stuff of how you do this. Yeah, easy as pie, right? Is it really that easy? Close. I mean, sometimes that is all you have to do. Though additional times, there are some other steps you'll need to do. Frequently your application will have to be aware of the acceleration. So you may have to do some configuration. So if you're using an FPGA or a GPU, you'll frequently need to load the code or the kernel onto that card and run it. And you'll have to set up shared memory to speak to it. Sometimes you'll need to mount the device as a volume in the pod. This happens quite a bit with some of the networking components. Basically, then it'll appear like it would appear in a normal application. These containers do have some advanced privileges, but with some of the access control and some of the more advanced container runtimes, you are able to isolate that to just be using that card. And then there's annotations to use the device plugin. So for instance, if you're using SRIOV with the Multis plugin, so that's single root IO virtualization, which is a way of exposing just a portion of a network card to a container. You'll also have to add an annotation, which again, just a 1-line entry pointing to that custom resource definition for the network you're going to be using. So as you do this, there will be a few nuances depending on the type of accelerator you're using and how mature and well-developed that device plugin is. But really, even in the most complex case, it's really not that challenging, and it's much easier than using it on a standard server. You may be wondering, well, that's great, but I really have high throughput application needs, and I need to be aware of NUMA. So this is NUMA's the linking of your CPU, your memory, and your IO cards to the same node. A lot of cloud servers and edge servers have 2 CPUs. And if you have your workload on CPU 1, you don't want to have to ask CPU 2, hey, can I use that card? It's a lot slower. And starting with Kubernetes 1.18 and Topology Manager, this actually just happens for you. So when you ask for a static config, so you ask for a specific amount of memory, CPU, and acceleration resources, it'll make sure that they're all on the same node. This is something configurable within the Kubernetes infrastructure, and as long as that's enabled, it's nothing you have to worry about as an application developer. Another cool thing you can do is, you may have a workload that doesn't require to use all of these resources. You may have some really big FPGAs and GPUs out there, and you only need to use a fifth of it or a third of it. Well, that's great. You can still share. Some of this is enabled today. It's different levels of maturity. The SRIOV with network cards, that's very mature. Some of the others, it works, but you may have to be extra concerned and aware of how it works when you're looking at things like multi-tenancy. So you may want to, even though you can share these devices, you probably only want to share these devices either within the same pod or at least within the same namespace. So you really want to be able to trust that all the applications that are using that individual card aren't going to do anything malicious and try to read memory across the card. I expect this to mature over time, but this is available today, and it really does help you to right-size your workload and scale things appropriately. So cool. We've talked about how application developers can use Kubernetes and hardware acceleration. We've talked about why you want to use it. Now let's really get to the hard part. The operators have to do quite a bit of work to enable this, right? Well, let's talk about what has to happen here. So for doing infrastructure management, if you've ever managed any kind of special purpose cards, and this can even just be a smart NIC or a video card. And with the edge, we're talking about, thousands or tens of thousands of locations with, hundreds of thousands or millions of servers, depending on your size, right? That's going to be daunting, right? You really need this all to be automated and easy. So you have to install and update drivers. You have to update firmware on the cards. You need to monitor the health of the cards. You need to integrate that into your inventory system. With Kubernetes, you need to install the device plugin. You frequently need to set up a custom resource definition. Then you need to map the accelerators properly to the right NUMA node on the right server. You need to run a device daemon on each server to keep track of that. And then there's all kinds of other setup. You have networking setup. You know, it's like, God, why do you want to do this, right? You're sitting here thinking, Randy, you've sold me a bill of goods, but it's just going to be impossible to manage. Well, fortunately, there's a few options for doing this. We've seen some of the traditional automation using Ansible and SSH, and some of the more popular vendors do use that out there for their hardware acceleration. But that's still kind of going out of bounds of Kubernetes. And we really want this to run on top of Kubernetes. So no matter which flavor of Kubernetes you're running, as long as you're running a standard version of Kubernetes or a supported version of Kubernetes, you can use this device plugin and this hardware acceleration. So again, you're not necessarily worried about, does your Kubernetes vendor support your card? You really just need to worry about, does your card work on that server and that OS? And there are some ways with a lot of the Kubernetes systems where you can have multiple OS versions running within the same cluster. And with KubeVirt, you can actually have VMs running within the cluster, and you can have a worker running in a VM on a worker. I know it's a little confusing, but again, there's a few options when you have to worry about kernel versions for older OSs, but ideally we're using new cards and they'll work with the new OS. And we're also working with vendors to extend support for older cards to work on newer versions of the OS. All right, kind of led up to it. Now here's actually how we can make it all fun and easy. So let operators use the work. And we're not talking about communications providers or service providers, or cable operators, right? We're actually talking about Kubernetes operators. And if you've done some work in Kubernetes on a standalone cluster, you've probably used these to install something like your logger or your data analytics. Well, you can use the same mechanism for managing your hardware acceleration. It could be as simple as running as kube control create, and you can pull it off of somewhere like Docker Hub, which is a trusted source for downloading operators. Once you're in production, you'll probably want to have a local copy where you're installing it, and you can do it under version control. Again, you just put that out there, and it does everything for you. It'll check all the nodes. It does need to run as a privileged container, so you can't do it as any user. So, user without any privileged access, they can't actually run it. And this is a Kubernetes user. But you just kind of go out and you put it out there. It'll, if you have the driver container, you can actually load the kernel module from within the container. You can update the firmware from the container. Actually have this then do monitoring and then feed that monitoring into the monitoring system you're using for Kubernetes. So your Prometheus and Grafana alerting and monitoring, and using Kibana or whatever tools you're using to manage your logs and your alerting, they're all there, right? You're using the same API endpoints. And you can even set it just automatically upgrade. You can do manual, but if you're doing automatic upgrade, you can just point it to a local repository and manage it that way. So it's just kind of like set it and forget it. And when things go wrong, you don't necessarily have to go in and muck and see what's going on. And trust me, I've had to do this quite a bit with some of the stuff on my home cluster. All you do is just restart the operator, which basically means you delete the pod. It comes up again, and then it looks and says, hey, what's going on? Let me go and check out all the nodes. Let me see if there's anything new. Let me make sure everything's in a good state. Again, it has to be done that way, but that's typically the way operators work, and it's great. You can just kind of redeploy, and it'll often fix the issues you have. You may need to change a configuration setting with the operator or have had some other change, but typically you just kind of restart the operator, and it really is magic. I know it sounds fanciful, but I mean, just last week I had a typo in the backend storage with setting up the logging, and All I did was delete it, start it, and copy and paste that extra letter in, and it worked. All right, so it's great, nice and easy to do. So are we there yet? Can we just go and download this for any accelerator card? Well, sort of. All right, several vendors actually are providing device plugins today. Most of the major vendors for FPGAs, GPUs, SmartNICs actually conform to some standard APIs with DBDK. So a lot of those are just there out of the box. So you can have those. Not all of them are providing operators. And of those operators, some of those operators are limited. So they may not have all the capabilities there. But even just over the last 6 to 12 months, we've seen a lot more adoption of the device plugin and the operator plugin. Again, we're seeing quite a bit of adoption. We're talking to several of the vendors out there, and a lot of other people are, and we just need to kind of really adopt this as our standard model and not worry about some of those other automation tools. And let's focus on the operator for deploying our hardware and for deploying our hardware acceleration. And operators are also great as an application developer. You don't need to be managing hardware for an operator. It's really a general Kubernetes tool, which really makes it much easier for deploying and much more self-sustainable. All right, so thank you. I really appreciate you taking the time to listen to me talk about hardware acceleration at the edge. You may be wondering, yes, this is great. How do I get more engaged? Well, come to the Open Adrenaline site. We have a white paper and some other content there. You can email me. My email is at the beginning of the presentation. You can email snaps@cablelabs.com to talk to the team at CableLabs. Another thing is really work with your hardware vendors to actually start using the operator. Some of the vendors that haven't used the operator, they've been doing, the more traditional automation tools. And this is just kind of out of market need. Again, if you're purchasing software, talk to the application developers and see if there's something that can take advantage of this acceleration. Especially as we're looking at the telecommunication space, we're accelerating the data plane with 5G. There's very tight latency requirements there. So again, a lot of this can be done better and more efficiently on FPGAs or GPUs or SmartNICs. So, look at it. You may have to evaluate. You may have sometimes where you'll just need to run it on the CPU because that's available. But let's really start working on it. And again, try it out. If you're a member of CableLabs or one of our NDA vendors, we actually have a lab set up that you can use. And there's several other vendors out there that have labs out there that you can use, or you can just spin it up like I did on my home system and get a little GPU and play, and it works. So thank you very much for your time.